Hello everyone. In this video, we are going to do 4 case study questions. There are 4 questions of case study from the chapter Polynomials, class 10th. So the questions which we are going to do in this video, questions that we are going to do this video, let me show you. This will be our first question. Say one. This is the second. This would be third, four. Right. So let's begin with the first question. The case study question number 8, it says, Neeru saw a creeper on the boundary of her aunt's house, which was in the shape as shown in the figure. So this was the shape, right, of the creeper. Answer the following questions considering the creeper has a mathematical shape as shown in the figure. Right. So now, based on this, we have to answer the questions. So I'm going to type the first question. So if I type the first question over here, it says number one, this shape, right? The shape of this polynomial. So the shape of this polynomial represented. What shape you can see, right? This is parabola. Parabola can be like this, or this is also true. Sorry, downward one. So this is a parabola, and here it is has to be quadratic, right? This is this kind of shape is called parabola, right? Whether this or this, and that is represented by a quadratic polynomial. So that was the first. Coming to the second part is how many zeros does the polynomial shape of the creeper have? So zeros are what? Zeros are the x coordinate. It is the x coordinate of the point where the graph touches the x-axis. So 1 0 is this, and the other 0 is this, right? So remember, it may not have 2 zeros. Like if the polynomial is passing like this, you'll say it has no zeros because this polynomial or this parabola is not touching the x-axis, right? And if it touches the x-axis like this at one point, then it will have 1 zeros. As of now, we can say it is touching the x-axis at 2.1 here, another here. So it will have exactly 2 zeros. The third part says the zeros of this polynomial represented by the graph. So you can see this is what the graph, and they are asking the zeros of the polynomial. So what are the zeros of the polynomial? It is the x coordinate, only the x coordinate, right? X coordinate of the point where the line touches the x-axis. So not line, graph. So this is the point, and this is another point. And what are its x coordinate? -2 and 4. So -2 and 4 are the two zeros of the polynomial. So option A is correct, right? It's 4 -2. So it's not a coordinate, right? Right. It's not an ordered pair. Zeros are not ordered pair. This is not an ordered pair. So it is, you can write even like -2 or 4. Doesn't make difference. Well, not keeping in a ordered pair like this. Fourth part is the expression of the polynomial represented by the graph. So a graph, as you can see, is given over here, and we have to select or we have to frame a polynomial which is representing this. So for that, you note the two zeros, right? And what are the zeros? It is -2, and the other zeros, I'm using alpha and beta to denote the zeros, right? We know the zeros now. And in order to frame the polynomial, the formula is k times x square minus the sum of the zeros times x plus the product of the zeros. So k can take any real values. What is the sum, right? The sum will be the sum of these two, which is what? It is 2. As you can see, the sum of these two is +2. But this minus sign is for this formula. So this is 2 times x plus product of the zeros. What is the product of these two? It's -8, right? So it is -8. This was plus. Plus minus is minus. So this is x square minus 2x minus 8. X square minus 2x minus 8 is the correct option. That is option B is correct in this case. So now you can see that this is the polynomial from your previous part representing this graph. Now we have to check for what values of x. For what values of x the result is minus 5. Well, this is an MCQ. So what you can do, you can one by one place x as 3 and x as minus 1. On the case where you get minus 5 is the required value. Let's say if I do it, placing x as 3 first from the option A, what is we are getting? This is 3 square minus 2 times 3 minus 8. So this is 9 minus 6. 2 into 3 is 6 minus 8. 9 minus 6 is what? 3. 3 minus 8 is minus 5. So yes, this one is correct. Option A is correct. But then we have to check for the other values as maybe more than one correct option. Not option. As you can see, the B part can be both A and B. That's the reason we will not decide the answer. Now, for the second part, I'm going to replace x as minus 1. So check here replacing x with minus 1. So minus 1 square. Again replacing this x with minus 1, minus 8. Minus 1 square is positive 1. This will give you positive 2 minus 8. So this is 3 minus 8 is minus 5. Yes, even this is also true, right? So the correct answer will be what? Both A and B, that is option C. Now, what I'm thinking that if it is not, assume that it is not an MCQ, then what should you do? How will you determine the values of x? So what you can do in such a situation when the zeros are not given, well, sorry, the options are not given. So you simply equate this polynomial with the result that is minus 5 and solve it. First, what I'll do, I'll bring them in the standard form by transposing minus 5 to the left hand side. So minus 8 plus 5 equals 0. So this is x square minus 2x. This is what? Minus 3 equals 0. Now, after doing so, we are going to do middle term splitting, right? So for middle term splitting, factorization by middle term splitting. So from the, let me once again write down over here. This is the polynomial, and from the factors of 3, I need minus 2x. So this is x square minus 3x minus x minus 3. So what I did here, I simply wrote minus 2x as this is minus 2x plus 3x, right? You must be knowing that from the factors of 3, that is 1 and 3, we have to obtain minus 2. Now, if I take common between first two term is x, so it is x minus 3. Common between last two term is 1, so it is x minus 3 again. So it's x minus 3 into x plus 1. Now, equate this with 0. On equating this factor with 0, we got 3, and equating this factor, the other factor, with 0, I got x is equal to positive 1. Check. Isn't that the same answer? Yeah. So this method we will apply in case if it is not an MCQ. Now we are on case study question number 9 from the chapter Polynomial, class 10th. Now if I read the information, it says two friends, Trisha and Rohan, during their summer vacation went to Manali. They decided to go for trekking. While trekking, they observed that the trekking path is in the shape of a parabola. The mathematical representation of the track is shown in the graph over here. Based on this, we have to answer the questions followed. So if I write down the first question over here, the first question is this. It says the zeros of the polynomial whose graph are this. So by now you must have understood that what are the zeros? It is the x coordinate. It is the x coordinate, also known as abscissa, of the point where the graph touches the x-axis. So we can see that the graph is touching the x-axis at 2 points, that is minus 4, 0, and the other is 7, 0. And its x coordinate are what? Minus 4 and 7. So minus 4 and 7, that is option B is correct in this case. Now, in the second part, the question is what will be the expression of the given polynomial? Right. So we know the zeros of the polynomial from the previous question or previous part. Now we can find the polynomial. And for how to find the polynomial, it is x square minus the sum of the zeros, which is alpha and beta here, that multiplied by the product of the zeros. So since we know the alpha and beta, let's say I take alpha as the -4 and beta as the other 0, which is 7. So what I can do, I can find the sum and the product. So sum, which is what? Alpha plus beta. The sum of this is what? -4 plus 7 is 3. And the product of the zeros is the product of these two, which is -28. Now, what we are going to do, simply replace this sum and the product, right? So this is x square minus, what is the sum from here? It is positive 3, so it is 3x. Now, this minus sign is because of this formula minus, plus the product of the 0, and the product is -28. So plus minus is minus, so it's -28. So when I check the answer here, do we have this? I don't think. This is no, this does not match with this. This does not match with this. So what you can see here that I told you that k can take any real values. So what in case if I take minus common from here? So if I take minus common from here, the expression changes, right? So if I take minus common, keeping k as -1, right? It is the sign will change inside. So it will become negative x square, positive 3x, and positive 28. So therefore, now if I compare our answer, I can see we have one answer. So option D will be correct in this case. Well, if I talk about this, this is also true. This is also true. This is also a polynomial. We generally leave the answer over here. But as I said, a given expressions of a polynomial can be represented since k is an arbitrary constant, k can take any values. In case if I take k as 2, then the polynomial become 2 times x square minus 6 times x and minus 56. Right. So there can be infinite number of ways by which a polynomial can be represented. Now let's come to the third. Well, in the third part, they're asking find the product of the zeros of the polynomial. They should have given this before this second part. Well, we have already calculated. As you can see, -4 and 7 are the zeros of the polynomial. Let's say alpha as -4 and the other polynomials, other zero as beta as 7. So we have to find what? The product. So the product is what? Alpha into beta, and this multiplied by this is -28. Should have been asked before the second part. In the fourth part, right? The fourth part says the zeros of this polynomial. Well, this is what our polynomial, and we have to find the zeros. This is not has anything to do with the graph. So what you can see that in order to find the zeros of any polynomial, the method we use is factorization. Now check here. This has only two terms and we cannot take anything common, right? Then we cannot go for middle term splitting as there are only two terms. In that case, we use identity. Can I write 9x square as 3x whole square? And 5 as what? Under root 5 whole square? I can write, right? Now, check here. Uh, this is the identity, what is called a square minus b square, better known as the third identity to most of you. This can be factorized. This expression can be factorized using this identity. So if I do so, it's a plus b into a minus b. So a is what? 3x, a plus b multiplied by a. This is a plus b multiplied by a minus b. Well, the order does not make any difference. You could have written minus over here or plus over here. Now, once we have done this, we have to get the zeros. And how do we get? By equating them with 0. Like equating this with 0. The first factor with 0. What should I get? It should be minus under root 5 by 3. And equating this with 0, that is 3x minus under root 5 with 0. What we get here, same way, if I transpose root 5 to the other side, it is positive root 5 divided by 3. Yes, so these are the two zeros. So this is 3 root 5 in the numerator. Yeah, this one. Yes, root 5 by 3 and minus negative root 5 by 3. Yes, this is the correct answer. Now let's come to the next. In the fifth part, it says if fx is equal to, this is fx, right? Fx is equal to x square minus 13x plus 1, then find f7. Should be very easy. I mean, a student of class ninth also can do, because we have done these things in class ninth. So we know fx as what? Fx is x square minus 13x plus 1. And what you have to find out is f4. That means wherever there is x, we'll replace by the number 4. So 4 square is 16. 13 into 4 is how much? 52 plus 1. So now this is 17 minus 52. And this is f4, right? This is our f4. We need to write down. This is f4. So now it is 17 minus 54 is what we have to do. It's minus 35. Yes, it is minus 35. There is an option. Minus 35b is the correct answer in this case. So we are now on the 10th question of the case study polynomial class 10. So if I read the case, he says Pankaj's father gave him some money to buy avocado from the market at the rate, and the rate is given in terms of a polynomial px, where alpha and beta are the zeros of this polynomial. Now we have to answer questions based on this. So if I see the first question over here, so first question is what? This is find the value of alpha and beta, where alpha is smaller than beta. Okay, this is the polynomial, and how to find the zeros? Well, alpha and beta are zeros here. So we'll be finding the zeros of this polynomial, and we'll be using middle term splitting. So for that, I will be factorizing first 128. From the factors of 128, I need 24. So 2 6 times 4 times 2, 32 times. Okay, now we need to do it further to 16 times. Yes, we got it. So you can see that this is 8, right? And this is 16. 8 plus 16 is 24. So this is what we will do here. Let's say if I bring down it here, this is x square minus 16x minus 8x plus 128. So what I did over here is to split the middle term. The middle term was 24x, and I split it like this. So if I take x common from the first two term, it is x minus 16. If I take minus 8 common, this is x minus 16. So finally it is x minus 16 and x minus 8. So equating this with 0, we'll get x as 16. And equating this with 0, we'll get x as 8. So 8 and 16 are the zeros of the polynomial. So they're saying alpha being smaller than beta. So first we have to write alpha and then beta. So first 8 and then 16. So this is B part is the correct answer for this question. In the second part, they're asking to find the value of what? Alpha plus beta plus alpha beta. Well, we have already calculated the value. Alpha was how much? Alpha was 8 and the beta was 16. So that's very easy, right? We are simply going to replace alpha here with 8, beta with 16 plus 8 into 16. So this is how much? 24 plus 8 into 8, it's 64 into 2, 128, right? So what I did here, I just replaced alpha and beta. So on placing alpha and beta, we are getting this. And their sum is how much? 128 plus 24 is what we have to do. That is 152. That's very easy. That was option C. In the third part, This is the third part. We have to find the value of P2. Well, this is what Px, right? This is Px. So P2 is going to be what? Simply replacing x with 2. So this is what? This is x square, that means 2 square minus 24x, that means 24 into 2 plus 128. So 2 square is 4 minus 48 plus 128. So this is how much? This is minus 44 plus 128. Right. So we just need to subtract 44 from 128. That comes out to be 84. Yes, it should be 84. So D is the correct option for the third part. In the fourth part, it says if alpha and beta are the zeros of this polynomial, right? And what we have to find out is 1 over, we have to find out the value of 1 over alpha plus 1 over beta. Now, what we are going to do, let me show you. First of all, I wrote this polynomial and I'm writing the standard form of a polynomial, which is ax square plus bx plus c. Why did I do so? This is because I can tell you what is a here. A is the coefficient of x square, which is 1. What is b, the coefficient of x, which is 1 again. And what is c here? C is minus 2, comparing these two. Now this I have obtained so that I can get this sum and product. That is, sum of the zeros is minus b by a. So negative coefficient is minus b over a. So alpha plus beta is equal to minus 1 over 1. That means alpha plus beta is minus 1. And if I ask you what is the product of the zeros, that is alpha into beta, which is c over a. So from here you can say that c is what? C is minus 2. So minus 2 over 1 is minus 2. Now, once we have got, you might be wondering why I'm getting sum and product instead of alpha and beta. This is because now if I have to find this, we have to find what? 1 over alpha plus 1 over beta. And if I simplify by taking LCM, is going to be beta plus alpha. Well, now we know the value of this, which is minus 1. And the value of this is what? Negative 2. So that results to give you what? This is, yeah, the value of this is minus negative 1 and the value of this is negative 2. So they get cancelled to give you half. Yes, we have an option here. So half is the answer. Now, many of you might be thinking that why did not we factorize this? Why did not we factorize this to obtain alpha and beta and simply plug in over here? Well, according to my observation, I have found that in most cases of a question like this, we do not get the values. It's not easy to factorize, or it's difficult to get their zeros. Let me try here the alternate method, but that may not be true in all cases. Let's say if I factorize from the factors of 2, I need positive 1. So you may write 2x minus 2. So if I take x common, it is x plus 2 minus 1 common, x plus 2. So finally it is x plus 2 and x minus 1. Equating this with 0, it is 2. Equating this with 0, it is 1. Now we can say from here, as I said, this is not always factorizable, but this case, in this question, we get alpha as 2 and beta as 1. So you may simply plug in here 1 over alpha, that means 1 over 2, 1 over beta, that is 1 over, I made a mistake, this is minus 2. 1 over beta is this. So this is basically minus, I should write in the numerator. So minus half plus 1 is positive half. Yes. In this case, we can do by any of these two methods I explained you. In the fifth part, it says if the sum of the zeros, uh, if the sum of the zeros of this polynomial is equal to their product, then we have to get the value of k. Okay, first thing that I'll do is to write the polynomial in the standard form. The general equation is what? ax square plus bx plus c. Now compare these two. What is a here? That is coefficient of square term, which is k. What is b? The coefficient of x, which is 2 in this case, and c, the constant term, which is 3k. Now, what next? They are talking about the sum and the product. Okay, so what is the sum of the zeros of a polynomial? Sum is alpha plus beta is minus b over a. So alpha plus beta comes out to be minus of b, that is negative 2 over a is k in this case. And if I find the product of the zeros, it is what? C over a. So the product of the C in this case is 3k, and A is what? A is k. So it can be reduced. So we got alpha beta, which is the product, right? So we got alpha beta as alpha beta, that means alpha into beta. So product of the zero is 3, and the sum of the zeros is minus 2 over k. Now, when you read it, you can see that the sum in this question, we are given that the sum of the zeros is equal to the product. That means we can equate these two. So if I equate minus 2 over k, that is the sum, with the product, which is 3, what do we get? 3 times k by cross multiplication, minus 2, or I can say that k is equal to minus 2 over 3. This is what I got the answer, and there is an option, that is minus 2 over 3. This is question number 7, case study question for the chapter polynomials. So what the question says, it says that in a soccer match, the path of the soccer ball in a kick is recorded as shown in the graph. So this is the path, as you can clearly see, this is the path over here. Now, based on this above information, we have to answer the following question. So question I'll be typing one by one. So the first question, if I type, let's say if I remove this, right? The first question says the shape of the path of the soccer ball is a what? So the shape, this kind of shape, you can see once again, this kind of shape, right? Whether it's an upward opening or downward opening is called what? Parabola, right? So this is generally represented by a quadratic polynomial, right? So we can say correct answer is parabola. In the second part, the question here is the axis of symmetry of the given parabola is. So axis of symmetry is what we have to find out. So what is axis of symmetry? You can see that as of now, if I make this is the axis of symmetry. So you can see from here that this axis of symmetry is what? Parallel to y-axis, isn't it? This is the y-axis, and this line or the axis of symmetry is what? Parallel to y-axis. So we have an option over here, as I can see. C part is the correct answer for this. In the third part, it says the zeros of the polynomial represented in the graph. So we have to find the zeros of the polynomial. So what are the zeros of the polynomial? Zeros of the polynomial is the x coordinate. One more time. Zeros of the polynomial is the x coordinate of the point of intersection, right, of the graph with that of the x-axis. Now, one more time, you can see here that the graph is intersecting the x-axis at these 2 points. One is this, another is this. So the graph is intersecting the x-axis at these 2 points. One which is represented by minus 2, 0, and other which is represented by 7, 0. So the x coordinate of these 2 points, right? So x coordinate is what? Minus 2, and the other is 7, right? So it's minus 2, 7. Minus 2 and 7 are the two zeros of the polynomial. Are the two zeros of the polynomial. In the fourth part, question is which of the following polynomial has -2 and -3 as the zeros. So you can see below are few options given over here. So instead of placing these values over this to determine which of them is correct, there is a shorter way. What we can do here is to frame a polynomial using these two zeros. So and what is the rule? It is k times x square minus sum of these zeros. Zeros are alpha and beta generally taken, plus the product of these zeros, that is alpha into beta. Well, k is any real values as a constant. So let's say this is x square minus sum of the zeros. So what is the sum of these two zeros? Is it -5? It is, right? So sum of the zeros is -5 times x plus the product of the zero. What is the product of these two? -2 multiplied by -3 is what? +6. Now, if I open this bracket, I say this is x square minus multiplied by minus is plus. So this is +5x plus 6. Now, if I compare my answer with the options given here, I can see, yeah, D is correct over here, right? So D is the correct answer in this case. The fifth part, in the fifth part, it says what value of x, for what value of x, the value of the polynomial fx, which is given by this, is 9. Right. So first of all, let me write down the polynomial once again. The polynomial here, which is px, is equal to, sorry, they have written fx. So we should also write fx. So fx is equal to x minus 3 whole square plus 9. And then they are asking when, for what value of x, what should be the value of x so that the result is 9. Well, you can estimate directly that I have to get 9, so clearly this must vanish. But still, let me do as if I don't know the answer. So in that case, I will go first placing x as 1. So if I place x as 1, so it's 1 minus 3 the whole square plus 9. So 1 minus 3 is what? Minus 2 whole square plus 9. That is 4 plus 9. That results to give you 13 and not 9. So therefore, this is not correct, right? F placing x as 1 is not correct. Then we will choose the next option, that is 2. Let's say if I find f2, so wherever there is x, I'll be replacing with 2 plus 9. So 2 minus 3 is what? Minus 1 square plus 9. This will give you 1 plus 9, which is 10, but not 9, as we are looking for 9. So this is also not correct. Now we have other options, that is option C if I take, which is 3 in this case. So we have third option, that is 3. So replacing x as 3, it results to give you 3 minus 3 the whole square plus 9. 3 minus 3 is 0, 0 square is 0, 0 plus 9 is what? 9. Yes. So we'll say that C is the correct option. So we can say that when x is 3, the value of this polynomial is what? 9.